I did a better job of getting things set for E period, so they actually got made more headway with the problem. So you may not be able to finish all these problems today, but I like you guys to make a pretty good dent in it. And I won't make this due until Friday, but if you need more than Friday, if you're feeling like a little stressed to get it done by Friday, then I'll accept on Monday also. But this is intended to help you prepare for the test, right? So let's take a look at the olive oil cake. Okay, so here's a slice, right? I'm not gonna eat it yet. It's so good. I want to eat it right now, but we'll wait. Be patient. Um, so for the olive oil group, what were your dimensions? What was your radius? 4.5 inches. Okay. What was your height? 2 inches. Okay, cool. And of course, what is the shape of it? Cylinder, right? Okay. And by the way, you will be provided all the formulas for all the shapes for the test on Thursday. So volume is pi r squared h. I'm not going to calculate because they should calculate themselves. So let them handle it. But it's pretty straightforward. Um, Now the surface here, the lateral area is going to be the perimeter times the height, but the perimeter is a circle, so it's just 2 pi r times h. The total area is the lateral area plus what? For a cylinder. So the lateral area plus what else? Two bases. Yeah, good. Okay. Which of course is going to be 2 pi r h plus 2 pi r squared. Okay, I'm gonna let them handle it. Okay. This is where the challenge comes into play. Number two. Okay. Sure, that's fine. Okay. So here's a slice. All right. We'll assume this is a 12. Okay. I tried to do my best at it. Okay, so I didn't type it. We'll assume this is a 12 because we have 12 students, right? So we'll assume this is a 12. This is the part that's gonna be a little tricky. Let me clear this. So if I want to find the volume of the slice, this is going to be true for all the desserts today, for every single dessert. If I want to find the volume of the slice, what do I do? Go ahead, Colette. Yeah, just 12. Well, you multiply by 1/12. I know what you meant, but because you divide by 1/12, actually multiply by 12. But yeah, you take 12 and divide by 12. So that's easy. That's super easy. This is the challenge. The total surface area. Okay. Let's take a hard look at the slice here, okay, before I eat it. So if you think about it, this where I'm pointing right now, what's the shape of where I'm pointing right now? It's a rectangle. And you got another rectangle. Now, if you think about it, it's like, let's crumble down. How long is it this way? That's going to be what? The radius. What's this going to be? And we said 4.5 and 2. What's 4.5 times 2? So you have 9 and 9. Okay. Good. So you have 9 and 9. So for the surface area, or I'll call it total area. But girls, can you wait a second so you can focus on the math here? Yeah. Yeah, don't worry, Zeus not going anywhere. Yeah. Sure, that's fine. Yeah. So total area of slice. You have two rectangles, right? Plus, now this part's a little tricky. Well, not really. Not really. Okay. So I'm gonna come up close to you guys. Does this look straight? That's rounded, right? So if you think about it, here, go ahead. Oh, wait. Yes, rounded. So if you think about it, let's say you're looking on top of the olive oil cake, right? You're looking on top of it, and you have a slice. And if I just focus on the slice, right? We did this in the last unit. What is that, guys?
Oh,
Arc
length.
sector.
Arc length.
Yeah. So, but we're not going to look at the length. We're going to look at the area. So what do you do? And this formula is provided in the test. You do 1/12 times the area of the circle. right? You do 1/12. Not here, the surface. Now, by the way, this surface doesn't happen elsewhere. Well, so it's 2. And now this part's a little tricky. This right here is lateral area, right? What fraction is of the whole cake?
12.
A 12. So you have the top, the lateral, the bottom. If you think about it, all this right here, 1, 2, 3, makes up a 12th of the total surface area, right? You guys see that? So you can't just do 1/12 of this surface area for number 1, because you got the rectangles as well, right? So now it's exposed. So here's what you do.
Just add.
It's gonna be 2 rectangles plus 1/12 the total area of the cake. So whatever the total area of the cake is, you have the formula for that, plus the 2 rectangles, which you know is 9 and 9, so that's 18. That's gonna be the total area for the slice of cake. Now, of course, you have different shapes. I'm gonna walk around and help you guys out that. The hula pie is gonna be a little tricky, and the bundt cake is gonna be a little tricky, but I'll help you guys for those groups who have that. But if you're stuck and I'm working with somebody else, move on to the other part. So for number 3, if you reshape this, so let's say you took the olive oil cake, made into a cone with a radius of 6 inches. What's gonna be the height? So take the volume that you get for number 1, use that same volume, set it equal to the cone formula, which is 1/3 pi r squared h. Use 6 for r, solve for h. Okay, number 4, average cost. So about $12.50. And by the way, I did look up like the bundt cake, which I totally screwed up, but it's okay. If you go to Nothing But Cakes, Nothing Bundt Cakes, sorry, they're great, and I have a big sale for Mother's Day coming up. But so get some for your mom. Anyway, that's about $40 for those cakes. So this is the deal to make. Yeah, for one, yeah, I know. Like seriously, the ingredients. I got a box of Deli Foods mix, a box of like instant pudding, a few other things. Actually, probably even less, I'm guessing. But yeah, let's go $12.50, right? Now, what if I double the radius? So if you double the radius, what's your scale factor? You learn a scale factor, 1 to 2. However, this cake takes up space. Takes up, what do we call when it takes up space? Volume. How do you deal with that when you try to change it, compare it to volume? Not 1 to 3. You cube 1 to 2. So now it's going to be how much more expensive? And to 8. So you got to multiply it by 8, which is going to be $100. That's crazy, right? So that's how you do that one. Then finally, from 5. I'm not going to answer this one for you. I'll just tell you how you'll set it up. Okay, we didn't do coding on this, obviously. Fine, whatever. But the hula pie we did, and actually the cookies I put powdered sugar, right? Let's say hypothetically the coating you put on your dessert is $5, like frosting, whatever you want to do, or fondant, whatever floats your boat, right? If you increase the rates by 50%, what will that do to the cost? So if you increase the rates by 50%, what's going to be your linear scale factor? If it was like, let's say it was 10, now it's 15, the radius. What's the linear scale factor? Or 3 to 2, yeah, 1.5 to 1. So now, if you compare it to the cost of the coating is covering not volume, it's covering what?
The surface area.
Surface area, exactly. So how are you going to deal with that ratio? Are you going to cube it or do something else? Square it, and that's what you do for number 5. What was that? Don't worry about that. We're not concerned because it's just because you have the cost for the original frosting. Now, what will be the cost of the new frosting for the bigger cake? Okay. So work on these problems. You want to start a piece of paper, some paper in the back for your specific dessert. So whoever you worked with, you may want to actually sit next to that person. So you guys, yeah, so let's move around. I'll help you out. And then after that, we'll talk about, oh, that's fine. Which one do you have? Okay. Yeah, then we'll do that second half of class. Yeah. So let's do this for another like 15-ish, 20-ish minutes. And then we'll talk about review for the test. But yeah. And don't worry about presenting this to the class. It's okay. I just want you guys to work on this stuff.
Do you have an extra paper? I think I don't want.
I could print some right now. We're gonna All right. Okay, guys, let's talk about 20. So 20 is actually excellent because this is that is just like the olive oil cake one. It was very similar. Very, very similar to the olive oil cake one. So here's how I would look at it. Treat it like treat it like a prison.
Wait, I did not read it.
You can do it two ways. I'm gonna show you I'll show you, you choose. Okay, so here's the deal. When you have a prism, you have to have two faces that are identical and that are parallel to each other, which is true for this sector, the slice, or portion of the circle. Now this portion is 45 degrees. How many degrees is a full circle? So you got to be fraction of that. So 45 over 360. So basically my base is going to be a sector, right? How do I find the area of a sector? 45 degrees over 360 degrees times the radius, so pi r squared. So that's 1/8 times 4 pi. That's right there. So volume, pi over 2. So volume is going to be base times height. So here's how to think of this. Yeah. I'm trying to find slice of cake, but it's not gonna work. Right. Or the second method, I didn't leave myself much space. The second method, which Faith had just mentioned, is you take the 1/8 of the volume. Okay, girls, let me talk. Thank you. Appreciate it. Why 1/8 of the volume of the whole cylinder? Because 45 is still 1/8 of 360. So it's like if I took this water thing here, right, and cut this down in a certain way. I took 1/8 of this, right? It's the same thing. Well, if I consider the whole thing, 1/8 times now my new base, right? My new base times the height. Now my new base is gonna be what? It's a circle, right? What's the area of the circle going to be? So 4 pi. And my height is still 4. You still get 2 pi. It's up to you. Whatever you can visualize or see. It's the unit review packet. So either way, it's fine. Now, for the total surface area, what are your shapes? You have two sectors, which right now, you did it earlier. You have two rectangles here and the one on the slanted. Then you have this rounded face, right?
Yeah.
The rounded face is part of the lateral area of the cylinder. And what fraction is it? 1/8. You're still doing 1/8, the circle. So yeah, I'll do the calculation. Yeah. So I'll do it up top. So for the so if you consider the whole cylinder, right? For the total surface area, let's consider the whole cylinder. The lateral area, which I'll give to you, is going to be 2 pi RH, which is 2 pi times 2 times 4. So you get 16 pi, right? But remember, you have to do 1/8 of it. That just gets you that rounded part. Then you have twice the base. 2 times the base of the sector. So that's 2 times pi over 2, which is pi. So you have pi, 2 pi, and they have 2 rectangles, right? What's the area of each rectangle, guys? So multiply by 2, you get 16. So altogether, you get 3 pi plus 16. Yep. And that's in square feet. Let's find out. I don't know. So you can practice it. Does that make sense? How I broke it down step by step?
Can you explain like what's on the test, like the type of problems?
Okay, so let's do a quick overview. Okay, so 23 is a good one. I'd recommend 23. That's kind of 23 is like the bunk cake one, actually. Actually, these are all fantastic problems. So here's what I would just that you guys know. Definitely know, well, no surface area and volume for all the shapes. Like know how to calculate for all the shapes, right? Depending on what I give you. So any shape is fair game, right? Like I'll ask to do it for a cylinder, I'll ask to do it for a cone, sphere. So expect each of those shapes to show up as a question. Know your surface area, know your linear scale factor ratios really, really well. So I think 3 is a really good one to do.
I like that one.
Yeah, because you really need to know how those compare. It's easy because it's all organized, but with the way it could be presented, what if I give you something that represents the area ratio and I want the volume ratio? But what would help, how do you compare area to volume more efficiently?
You put it back to the linear scale factor.
Exactly what Reagan said. Guys, listen, that's exactly what Reagan said. That's exactly what you want to do. Go back to the linear scale factor as a bridge, connect area ratio to volume ratio. Because the table makes it easy, but if you don't have a table and you're trying to compare area and volume, make a table yourself. Do it. Do it. Make a table yourself. That's fine. Also reshaping, right? Because if you think about it, we just did that for number 3 in the project, right? When you reshape the dessert into a cone, think about that. Know your pyramids. We talk about pyramids. So, I mean, I think this is a fantastic pack. Actually, I love 13 through 16. Those are fantastic problems. That's exactly what Reagan was talking about. Practice that.
Wait, 13 through 16.
13 through 16.
What? Oh, ratio.
Ratios. I mean, there's no.
It's 20 like a challenge.
Yeah. So do expect a challenge. Do expect something like 20 or 23, something funky. I'm not gonna say what, but something funky, dude. Or 32 is funky. 33 is funky.
Don't like 32. Wait, you go.
Practice it.
I'll take anything but 32, honestly.
Yeah, he's gonna put 32 is too funky.
Wait,
Try it.
Is 24 funky?
I think it's pretty easy. Because parallelogram is just base times height. And they have 4 rectangles. That's it. Yeah.
oh wait, that's a light work.
A plane, whatever.
Actually,
no.
here we go. Just got you. I have some back there. They're all. Okay, you guys should have it ready, but you guys should have it. Oh no, okay. Yeah, I have extra ones.
I did it. I already did the whole packet, but I want to do it all again.
I do everything like that. I just love the game.
Thank you.
Thank you.
And then office hours, here, you guys also do, your Delta math homework assignments, 25 and 29, you get the assignments.
Yeah, just do those again.
Those, practice especially 29 because it's got more.
Wait, here, I don't have to go.
We don't have light.
Bear in mind that we quizzed you already on prisms and cylinders, so. Probably a little bit less emphasis on that, but not saying it won't show up, but it's just more on the pyramid, the pointing ones in the spheres.
Wait, if it has like a curve, then you just